Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have sine 2x divided by a square plus b square sine square x, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what's our y. So there we are. That's our y. I know that my y is not in a very simple format whose antiderivative I know directly from first principles or even any of the identities slash rules we have learned so far. So our job in hand is to simplify y, right? So how do we go about doing that? When I look at my y, I notice that I have a sine square expression in the denominator, which is a square plus b square sine square x. And then I have a sine 2x in the numerator, right? Now I'm looking at if there is a possibility to connect these two terms, right? The answer is yes. And why is that? Because d by dx of sine square x is nothing but 2 sine x cos x, which is a sine 2x, right? So the substitution that we can make in order to simplify y is p equals a square plus b square sine square x, right? I know that my a and b are constants, so my d by dx of a square, or be it the constant b square, is always a zero, right? I differentiate this on either side. What do I get? I get my dt by dx equal to 0 plus b square times d by dx of sine square x, right? So my d by dx of sine square x is nothing but 2 times sine x into d by dx of my sine x, which is a cos x, right? So I'll get 2 times b square remains as it is, and I have a sine x cos x, right? I know that my 2 times sine x cos x is a sine 2x, right? So I can rewrite this particular expression as b square into sine 2x. So this is my dt by dx, right? So what is my dt now? Let's go to the next line. My dt is nothing but b square times sine 2x dx, right? So this is my dt. Now I go to my expression y. I notice that I have a sine 2x dx in the numerator, right? So now I can write my sine 2x dx using t, right? So I know that my b is a constant. Therefore, my sine 2x dx but a dt by b square. This is my sine 2x dx now. I go to my y, I know that I can replace and represent everything using t, right? I have a dt in the numerator by b square now. And then I also have my a square plus b square sine square x, which I can replace by t. And why is that? Because that's the original substitution that I've made, right? So I have integral of dt by b square times t. My b square is a constant. I can pull that out. So I can rewrite my expression as 1 by b square times integral of dt by t, which is nothing but a ln mod of t, right? I have solved this particular problem now, but then I cannot leave my final answer in the form of t. I'll have to rewrite everything in the form of x, right? I know that my t is equal to a square plus b square sine square x. That's the original substitution I made. So let's go to the next line and write our final answer in terms of x, right? So my y will be equal to 1 by b square times ln of mod of a square plus b square sine square x plus c, right? There we are. So let me highlight my final answer in pink. So I hope you found my content useful. Please do subscribe to my channel and support. Thank you.